Okay, I'll start. Hi, I'm Garrett O'Hara. Nice to meet you all. I'm going to be talking about why it seems that so many darn businesses these days are leveraging the technology of cloud computing. So first, first we must understand the differences between traditional hosting and what makes the cloud so special. So traditionally, there's a lot of barriers in place that disallows startups and sole proprietors to start hosting their application or their services online. Okay, and one of the main factors is hardware. You actually have to buy physical hardware. This requires you to negotiate with the vendors and figure out if you can buy these hardware at a good price, at a bulk retail price. You have to buy CPUs, RAM, motherboards, power, SSDs, disks, the whole 9 yards. And perhaps you might even have to buy, rack equipment and server racks. Additionally, you're going to need to hire some people to assemble all of these servers and technology. You're also going to have to hire them to maintain this. You're going to have to train them. You're going to have to hire them. You have to fire them. You're going to have to manage this IT staff. And that's all just for one geographic location. Let's say I did that in North America. Perhaps I want to now start serving clients in Southeast Asia. I'm going to need to do this entire process over again in a different country. Hire a whole new staff, maintain it, and the whole 9 yards. So with the cloud, this is where things are a little bit different. And there's a big concept of virtualization. What does that really mean? Well, you deploy your resources virtually. So you're not buying any physical hardware at any point. In fact, you're kind of just renting it from a cloud provider. And who are the cloud providers? We'll get to that in a moment, but it's a lot cheaper to get your company started in the cloud. They have pay as you go. In fact, they'll actually give you some credit up front just to start using their services and deploy some resources in the cloud. And then once you deploy them, you're only paying for a small portion of what you're actually using. Additionally, because there's so many people using these services, you're actually getting it at a highly discounted cost, so it's much cheaper. Additionally, these services are highly accessible. On the next slide, we're going to be looking at why. And they offer simple IT solutions through abundance of services that they offer. They make network engineering easy, security and hosting all pretty simple. All people without even a bachelor's in computer science can do. And then another concept is abstraction. And I listed it 3 times because it is so important in the cloud. Things feel too easy sometimes to make some really incredible solutions. Through their managed services, in a few clicks and just a really powerful graphic console like AWS's console, you could have a server up and running serving a database and have it public to the entire internet. So let's look at why things are so accessible. This quote puts it in perspective, 99.999 uptime. That's a pretty big number. In fact, when you look at it in terms of a whole year, it's what, 5 minutes and 15 seconds of downtime? That's pretty remarkable. And what's also more remarkable is that AWS can do this time and time again. It's not a big deal for them. It's because of their robust systems. And the robustity of their systems can be displayed here. Regions. They have 22 regions all around the globe. They have a region in every single major continent in the entire world. Every single region has 2 to 5 availability zones. What an availability zone is more of probably what you may think of as like a database, okay? Each availability zone is on a different power grid. This is so if you have resources deployed in one region, if you spread your resources across multiple availability zones, even if natural disasters occur, you can still serve your clients. These are fault tolerant because of the availability zones, but also each one of these databases have robust power systems, uninterrupted power supplies, great cooling. There's 24/7 IT staff in the databases. With cloud computing, there's this concept of auto-scaling, meaning that your servers will automatically grow the number of them in order to meet the requirements for the traffic on your services, and they'll also shrink when there's less traffic in order to save you money. Load balancing, we'll look at this later. This is, something you can put that filters all the requests and distributes the load among a collection of servers within a region. There's also database replication, which, kind of self-explanatory. Database redundancy, it helps keep your database up. If one of them fails, there's another one right there. So who owns the cloud? And when you ask that, you're really asking who owns the internet, because it's approximated that apparently 90% of the stuff that we interact with on the internet is all hosted on the cloud. Now, as you can see, Amazon is the lead company in this field at 33%, Microsoft in second, Google third. Those are the big three. Okay? So, all that sounds great, but why don't we actually look at a real world solution or a real world problem and see how we can leverage cloud computing to find a solution. So the problem is, suppose that you are a staff software engineer for a startup company. The CEO asks you to design systems architecture for your application your team has developed over the last 18 months. The application must serve millions of users in over 100 countries. Do that with minimal latency, it must be fault tolerant, and of course it has to be secure. Oh, also, when you pitch this architecture, the investors are going to be there, so make sure that you keep costs at a minimum, because they're really going to want to see a return on their investment. Oops, I went too far. And as every good engineer knows, you're also going to have to consider edge cases in your engineering. Here's some edge cases that we're going to work with. So you must have a production server and a database in each continent to ensure minimal latency. The application relies on the data that the users create, so we cannot lose that at all costs. Additionally, apparently marketing did a great job, and the application launch is going to have 500% the expected traffic on the production servers. So that's a pretty tall order. And if it wasn't for the cloud, I honestly wouldn't know how to answer that. Probably would have just changed jobs and picked something easier like being a doctor or an astrophysicist. But let's see what we can do with the cloud. So what do we need? We're going to be leveraging some of these techniques that's going to allow us to do this. Multiple application servers so we can distribute the load. Scaling databases so we can scale up the database based on the number of requests and data that we're storing. And also diversified graphical locations so that our resources are spread out, they're fault tolerant, and we serve all users with minimal latency. So this is a really high overview picture of what I came up with just within the afternoon. Obviously for something this large, it's probably going to be more than one diagram, but this actually does describe a lot of the technologies that are the core of what would encompass this. I apologize for the small text. I didn't realize that it was going to be this small. In the bottom left, I'm reminding us of the constraints and edge cases that we're working with. So we have our clients, millions of clients all around the world, and all of their requests are going to be routed by something called AWS Route 53, which is a customizable DNS server. And what this does is that it's going to be able to route the user's request to the nearest region that they are in. So the nearest place where my company's resources are towards them, so we can mitigate their latency. So first, the request is going to go through an internet gateway. Okay, an internet gateway is attached to every single VPC, and what that does is it takes the outside internet, the public internet, and is a gateway or a bridge into my VPC. What's a VPC? Virtual Private Cloud. It's essentially a private network, like your home internet. It's secure, and things inside of it can communicate, but unless if you have a direct connection inside of that private network, nothing else can communicate, hence the need of an internet gateway. The internet gateway is going to flow right into a public subnet, okay, and the requests are going to be filtered through a load balancer, okay, and we're going to distribute the requests amongst a collection of servers. That's the purpose of the load balancer. As you can see, here are our servers in this region, and we have them in 2 availability zones. Because if one of the power grids and a tsunami hits one of them, we can still process requests with the other availability zone. That's still going to be up. Also, because we have 500% of the expected traffic, these are in an auto-scaling group, meaning that if I'm receiving more traffic than this architecture can handle, it's automatically going to scale more servers, and the load balancer can distribute the load amongst those servers. Okay, so now this gets a little bit more simple. probably people have seen before. This is just writing to a master database, okay? And because we need to ensure that our users' data gets stored properly, we have these being stored, because we need to ensure that the user's data is safe, if the database is corrupt, we're constantly writing images, which are like snapshots of the database, copies of it, kind of, but compressed, into these storage buckets in the top right. We have a hot storage, that means it can be fetched really quickly, and then we also have a cold storage that can not be fetched as quickly, but it's great for long-term storage and a lot of data. We also have a replica of the database, meaning that if this master one has experienced problems, we can instantly start routing requests to the replica right there. As you notice, there's another part of this architecture right down below. That's hypothetical region B. And as you notice, everything's about the same as region A. That's good. That means that, no matter where the location is, I can basically just edit some configuration files and deploy an entirely new set of services in a different region within a day. So if I need to stand up a location in Frankfurt or something, I can do that. And that's all powered by Amazon and other cloud providers. So that was a high-level overview. Let's take it down a notch and see how a common computer science student could use this. As you can see, over here I've listed an amount of services that they offer, and this is really just scraping the surface. It's hundreds of services they offer. Machine learning, game development, augmented reality, crypto blockchain, data science. There are so many things you can do, and I encourage you to please take a look at it because it's really interesting. Let's look at a fun example. AI-powered Twitter bot. Okay, so let's use AI to analyze Jim Cramer's advice and then do the opposite. So if you don't know Jim Cramer, he's this guy, I guess on Wall Street or something. He has this show and he gives people financial advice. And because of the market, if you do short-term market and stocks, it's kind of gambling. So a lot of times he's wrong. A lot of times he's right. So doing the opposite is just kind of funny. So how can we actually do this? Let's run our code on Lambda. Okay, so we have a Lambda function. Let's web scrape what he says every day. I ingest that. I take that data and I run it through OpenAI. Do some semantic analysis, do the opposite of it, return it back to the Lambda. Now I have the opposite of what he said, and then I can just submit that in a tweet. That's kind of a fun little project. I just thought it'd be interesting. So I believe that's everything that I have for you. I showed you some motivations and how cloud computing can be utilized from a very high level all the way down to something more fun. So if anyone has any questions, please ask me now. Yeah.
Are there any disadvantages or advantages to different cloud providers, or they're pretty much the same all around?
That's a good question. They're really kind of just the same. Now, if you get into the nitty gritty, some of them are going to have slightly better prices in terms of this specific service that I need. Let's take computing, virtualization, VMs. If I need a server that's virtualized, maybe Azure does this better, but maybe AWS has better machine learning prices, so I can just stand up a model and then ingest data. Yeah.
Does the real estate require to house the cloud servers factor into this, or will it factor into this as more and more people use the cloud? Because the cloud still has to exist in a location somewhere.
Yes, it does. My dad actually builds a data center that houses the cloud. Not that he's the owner.
Will the real estate market affect the price of the cloud because you need a place to actually put this?
Yeah, they can stand up these databases in a lot of places that aren't very expensive. The cloud, I had to take out some content because I was running too long, but the cloud is almost $1 trillion market, which is essentially the same size as the semiconductor market. And it's because there's so many solutions. And the reason why the cloud is just, for 99% of companies, going to be cheaper than actual hardware is because all of the prices are abstracted. So there's so many people buying these resources that are rented by Amazon that even if you're just buying a little tiny part, even if you just have one server, you're still getting that at bulk prices because it doesn't cost Amazon anything to create a different price model based on how many services you have. So the more people that use it, it kind of actually drives the price down. And yes, you're right, it does cost something to actually build these data center locations, but that's an investment that Amazon makes. And they see their return with the services that you use. You know, they know that they're gonna get their money. Instagram, Facebook, or Facebook has their own service probably, but Uber, Lyft, these are billion-dollar companies. They have bills to Amazon that are tens of $millions per month. Amazon's revenue, if you wanna look at it, it's outstanding. It doesn't even look real. So I think the cloud is gonna be around to stay for a little bit. You can use other things, you know, hardware solutions for yourself, but there's a lot of solutions in the cloud that you might wanna take a look at. Any other questions? Yeah.
Yeah, so for the security of the AWS servers, is that covered by Amazon or another company?
Yes, so a lot of those things, the IT stuff is abstracted. When you actually spin up a server, it's a really cool process. You just log into their console, you select the operating system you want. They have an abundance of operating systems, a bunch of Linux distros, Windows if you want. And then you select how many like CPUs you want stored. But then anyways, later you can configure your storage. So you can totally lock it down, and you can basically just allow your IP address to, you know, peer connect into that via SSH or just, you know, other ports. You can configure the network. It's so customizable. So you can run your own security, or you can kind of use their boilerplate security, which is really good. And kind of answer your question, Amazon does, I think, take some of the risk. If their systems are hacked, they're not gonna screw you over. They kind of are providing a service for you, and they know that their security is good. And it's very rare that Amazon servers are crashing. That's why they have like 99.99% uptime. They pay people a lot of money to make sure that that doesn't happen. Because there's been cases in the past where Amazon's been down for a little bit and they lose millions of dollars per minute. It's kind of ridiculous. So they want to make sure that every client is served correctly, I suppose.
Okay, thank you.
Yeah, thanks.